Hey everybody, thought I'd make a quick video here for you. It's a little bit later in the day. Apparently the key that I had posted earlier with a short explanation did not load, so that should be up there now. But regardless, here's a quick video just so you can understand what we were talking about in class today as well. So the first thing is here, I have a little bit of a typo. We want to definitely cross that out and put the three dimensions that every solid can be measured are height, length, and width. Okay, so this whole section, as you'll see, is all about 3D shapes. We're going to talk about their volume. We're going to talk about their surface area. So a couple different things. We'll probably have a test at the end and then do like a week or two of a project before we let out for spring break. So first thing you got to know is a prism. Okay, a prism is named by the face, okay, or you could say the base, okay, I should say the base shape, either way, okay, and all lateral faces, what do we mean by lateral is usually, you know, up and down or whatever, or side to side, I guess, faces are on the shape, are in the shape of a rectangle, so that's how you know it's a prism. Is it'll have rectangular lateral faces. Okay, so if we look at this first one, you can see that we have this triangle on the top, okay, and that's a face, and then we have a triangle that would be on the bottom, and then we have basically these rectangles that connect it, right? Connect it down, connect the two bases. So since the base shape is a triangle, this is called a triangular prism. Okay, and again, as you can see, this is a face, is this triangle, this is a face, then we've got the one that looks like this, okay, and then another one over here, okay, so that's a face, and then also, let's not forget, we have the one that's kind of staring right at us here in the front, okay, and that's the face as well, so we'll put that kind of over here. All right, so in total, we have 1, 2, 3, 4, 5 faces. Okay. And then vertices, a vertice is at the corner. Okay, so vertice, just like a V, it comes to a point, right? So same thing here, vertices are all your different points. So there would be 6 in this case. And the number of edges, well, edges is on the outside. Okay, so there's 4. There's 5, there's 6, there's 7, there's 8, and there's 9. So there are 9 edges. Okay, this next shape is called a rectangular prism. Okay, it's got 1, 2, 3, 4, 5, 6 faces. It's kind of like a cube, right, or a Rubik's Cube that you guys see me playing with in class. Vertices, it's got 1 at each corner. 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 vertices. And the edges, of course, there are the 4 up on top, 4 on the bottom, and then 4 along the side. So there are 12 total. Okay. Cylinder. Cylinder has, let's see, basically 2 faces. Okay, or I'm sorry, 3 faces. Because you have the 1 here, you got 2 here, and then there are no real edges on a cylinder, right? Vertices, it doesn't have any. Edges, it's got 2, okay? Because you got the 1 up here that's all connected, and then 1 down here that's all connected as well. Okay, and that's called a cylinder. And then this last one, the base shape up here is going to be a pentagon, so it is a pentagonal prism. Okay, which means it has 1, 2, plus the 5 around the outside, so there are 7 faces. It's got vertices wise, it's got 5 on top, and then the 5 on the bottom, so that would be 10, and the number of edges would be 5 around the outside, 5 on top, and then 5 on the bottom, so they're 15. So hopefully at this point you're getting a good idea. There is a formula to figure these out, or a pattern. Okay, the number of faces of any shape, any prism, is you take the number of sides of the base and then you add 2. right? So pentagonal prism, there's 1, 2, 3, 4, 5 sides on the base. Okay, number of faces, add 2 to that number. Okay, vertices is just 2 times the number of faces. So again, pentagon 5, 5 times 2 is 10. And then as you can see, the number of edges, 5, 5 times 1, 2, 3, 5 times 3 for the edges would give you 15. So that number of edges is 3 times n. All right. So we're going to look at some nets, what are called nets, and the shapes that they provide. Using the nets provided for you, cut out the shapes. Don't worry about that. We did that in class. But as you can see, this prism, it's very similar to what's up above. The base shape in this case is a triangle, and then you've got the 3 rectangles that connect the 2 rectangles, right? So this is a triangular prism. Okay. Lateral face shape, just as we mentioned, since it is a prism, will always be a rectangle. Okay, number of faces, well, the base shape is a triangle, which is 3, so number of faces must be 3 plus 2, which is 5, which it is, 1, 2, and then the 3 rectangles. Number of vertices, take the base shape, which is a triangle, multiply by 2, so that would give us 6. And number of edges, take the base shape, multiply by 3, that would give us 9. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so what do they mean by draw the net? Well, the net, and you need to know this for tonight's homework, the net is the shape that you see if you were to lay it out on a piece of paper. So if it was no longer 3D, but rather that you just have this shape drawn on paper, and then you would cut it out and fold it, which is what we did in class. Well, the net shape of a triangular prism looks like this, with your 3 rectangles that connect the 2 triangles, right? And they would fold up, like this half folds up, this half folds up. They would meet right here at the peak of the triangle. Okay, so that's called a net. Next shape, 1, 2, 3, 4, 5, 6, 7, 8 sides. Okay, so this is an octagonal prism. Again, lateral face shape is a rectangle. Okay, so number of faces, we know it's 8 plus 2, which is 10. 8 times 2 is the number of vertices, which is 16. And 8 times 3 is the number of edges, which is 24. Okay, which again, 8, 8, and then the 8 edges around the outside here. Okay, so draw the net. Well, you got the 8 rectangles that connect the 2 bases. Okay, so we're going to draw 4 and 4. Okay, there's your 8. And then, of course, you have your 8 as well here. Okay, and there's your octagonal prism. So you have your base, and I actually forgot. I'm going to copy this and put it on this side as well. Not great, but you understand the point. Okay, so it'll kind of like, these 2 will fold in, and then the rest of these kind of fold around and wrap around it like a snake. Okay, so a couple examples here. Classify each of the following prisms for the given net. List the number of faces, edges, and vertices. Okay, so the base shape here is 5-sided pentagon, so this is a pentagonal prism. Okay, which has 5 sides, so the number of faces is 5 plus 2, which is 7. Number of vertices, 2 times 5, which is 10. And the number of edges would be 3 times 5, which is 15. And again, you don't need to know those formulas. You could just count them or fold it together, but it's just a quicker way to solve it. Okay, next shape here, triangle. Okay, with the 3 rectangles. So this is, again, a triangular prism. It's got 2 bases, 3 sides, so the faces would be 5. Vertices, 3 times 2 is 6. And edges, 3 times 3 is 9. Okay. This one's got, let's see, 1, 2, 3, 4, 5, 6, 7 sides, so that's a heptagonal prism. Okay, heptagonal prism has, let's see, faces, it's got 9. A number of edges, it's got 7 times 2, which is 14. And I'm sorry, I'm doing it backwards. So the number of vertices is 14. Number of edges is 7 times 3, which is 21. Okay, last thing we're going to talk about, we'll go through some examples here, are cross sections. So I gave the example in class as well, but if you think about like your barbecue, right? If anybody does any barbecuing, you know, your family, or even if you go to the Roadhouse, you take the meat off the barbecue and then you slice into it and you can see whether it's medium rare or whatever. Well, when you make that slice, that's called a cross section. Whatever shape that you see is called the cross section. Okay, so the next examples are basically doing that, like this triangular rectangular pyramid, because it would have, I assume, like a rectangle on the bottom, and then it comes across like this. It wants to know, well, what shape would it cut out? Like, what shape would be down here? Okay, that you would see when you open it up, like if you peel it back and open it up. Well, that shape would be probably going to be a rectangle, right? Rectangle or square, depending upon the base. If the base is square, then it would be a square pyramid. If the base is rectangular, it would be a rectangular pyramid. Okay, same one here. Okay, you cut it down through that cross section. If you peel it up or peel it in half and look, it's probably going to be a rectangle or a square. Okay, next one is not going to be a rectangle because you got like this 5-sided shape on the top, and if it's parallel to that, then it should be the 5-sided on the bottom as well. So, or in the cross section. So the cross section here, right where this orange piece cuts out, if you slice it through, it would be also a pentagon. Here, cuts it out. You got to think it's going to look something like that. So this would be a triangle for the cross section. This one's pretty simple. It would be a rectangle. And then this one would be, you know, cuts it out probably right there. So this would be a circle. Okay, so that's how you can think about cross sections. Okay, so cross section in this next example of a right triangular prism is created by a plane cut through the point shown and is perpendicular to the opposite base. So what they mean is they cut this plane out like this. They cut it all the way down to the other triangular base. They cut it out like that. So it looks, if you were to shade this in, like this window if they were to like peel it back after they cut through it. Well, what shape is that? Well, it's going to be either a rectangle or a square for that cross section. Okay. Then you have a cube. Well, if a cube, same thing, they want the shaded region where they cut. Well, since they're cutting at a diagonal, remember, the height and width are proportional to each other. Height, width, and length, right, are all proportional to each other. So if we cut it at diagonal, that's not the same height here. So now it's going to look like this when you take out that piece. Okay, so it's actually going to be a rectangle. Even though it's a cube is made up of a bunch of squares, a cross section diagonally like that, if they'd gone straight down, it would have still been a square, but since they went diagonal, that'd be a rectangle. Okay, last one. So triangle ABC is shown. What three-dimensional figure results from rotating the triangle 360 degrees, so all the way around, right? AC, all the way around this line. Well, that's pretty easy, actually. It goes like this, all the way around. Okay, right? So then you got to think like it's almost like an hourglass where it wraps around, so this would make a cone. All right, so that's it for today. We talked about cross sections, talked about nets, faces, vertices, and rectangles. And in preparation for tonight's quizzes homework that you have, so go ahead and complete that. And then tomorrow in class, we'll continue our unit on volume. I'll see you guys then.